All right. Okay. So audio is picking up. So let's go through again. So this week we'll be looking at constraints and integrity, and the two things are related and sometimes mean the same thing. Right. So for something to have integrity means that something you can trust. Right. Something you can hopefully believe in. Right. And so when it comes to database design, the core for all database systems is at least to have entity integrity and also referential integrity. And entity integrity just would mean that, so basically you have to be able to identify each entity. And you'd hear in some cases they would say you need to have a primary key. That is all around this thing called entity integrity. Right? So it means that having that one, at least you can say, okay, this specific row or this specific item can be identified by, right? And that also makes it possible to do these updates, deletes in a very targeted way. The database table that people designed, or well, I told you to design, was very poor because you insert something and you could insert the same person 2, 3, 4, 5 times. Right? That is going against integrity because it means that now there are duplicates in the system. In multiple ways. So you have to, as much as possible, if it's the same, if you really mean that the two things are the same thing, you shouldn't have 2 or 3 values representing the same person.
Let's say, because we have movie stars and we have movies. So let's say, like some Van Damme movies, and Van Damme was like all those movies.
Oh, yes. Okay, so that's fine. So you realize that in the design you made, Van Damme or whoever your actor was had other information about him, that maybe Van Damme lives in California, from US, he had an address and everything. But it would be good if you can pick and say, this record represents Van Damme in the start table. You don't want to insert and have 3, 4, 5 Van Dammes. And that was happening. Yes, I intentionally let it go, so that people realize that without having any integrity, it's very hard to manage the database. So, for example, you could pull up the record for Van Damme. You think you've pulled up Van Damme. He's now coming to Ghana to star in a movie, perhaps. You change his address, and there are other records in the system who are saying that Van Damme is still in California, right? So having the primary key helps to bring entity integrity, right? Just as for human beings, having an ID hopefully will bring some integrity because you can be identified. As opposed to you having multiple IDs, you are arrested. Hello, here you go. Then the next time, oh, this is a different. Okay, that's my cousin, brother, third cousin, twice removed, right? Okay, so next question.
In the case of this movie database, would it be useful to make the primary key the name of the actor?
Okay, so it depends on the design. For currently we use the name, and for simplicity we use it for maybe this week as well. But what will happen in real life is often we replace just having the name as the ID with something else, something that we generated, or something that we just give them as they come in, right?
So
in future, we'll be moving to auto-incremented ID numbers. For this design, those that for this week continue to use the name as the key, that's fine. But later, we'll ask you to think of a different type of key, maybe IDs. Why would we want to use IDs instead of just the name? Yes, 2 people may have the same name. And then in the case of movies, these days, I don't know, Batman, the Batman. 2016, 2014, 20. So, if they all have IDs, it will help. It will help out, right? Even Thor, I saw some Thor movies on YouTube that were not the official Thor movies. You see, someone has made his own Thor movie and he calls it Thor. And okay, wow. But for how long? Okay, so you realize that with entity integrity, it does mean 2 things. If everything should be unique, someone can say, well, then the whole row is unique, right? And that should hold. I mean, if you are going to say everything is different, every row must be unique. You can't have 2 of the same row. So that's a consequence of entity integrity. It means either there's a key or there's some way to identify you such that everything is unique. And some people, by design, and you see some new DBMS which are like this, where they will allow you to just say, well, don't even worry about saying a key. Put in your data, we'll handle it. But the other caution I was giving to you is, even if Kojo has a specific address right now, if you don't enforce that combination, or there's some way to identify it, the moment updates are coming in, you'd run into issues, right? Because then, what if I have moved and someone else is coming to live there? Is it the same person? So there are other questions that come up. So we have to design our databases carefully.
In the case of ID,
In the case of IDs.
if it's like, so if everybody is 001, 002, and somebody mistakenly uses 002, it's still going to compare it against the name, right? It's the same way you compare the name against an address.
Okay, so for IDs, it's easier to follow. So even here, we have students. Once you are given an ID, even if someone else comes after you, same name, and we've seen it, it's uncanny. Someone almost as well. Then the issue becomes, how do you differentiate one person from the other person, right? If at least you have an ID, so yes, databases won't be perfect. There will have to be some human intervention, something else to check. Say, okay, what else can we differentiate you with? And usually we use your username or your IDs, and from there we effect other changes. If you say you want to change your name, having the ID helps us to make sure that at the very least it's still that record we are dealing with. But when we don't have that, for humans, we run into issues. So either normally humans will assign an auto-generated ID or a slightly created ID, like your driver's license ID. You'd see part of your name in there, part of your your birth date in there, but at least it will still help to identify you uniquely. Right? And social security numbers, if you don't have it, please make sure you check.
I guess if you want to retain some sort of order, and in your database you have removed some of the entries, how is it possible that you can reorganize the ID numbers to reflect orderly, like 001, 002, 003, instead of 001, 005, 006?
Okay, so that's a good question. You can sort the information with a query. So you can do the select query. We are just doing select star. Over the course of the semester, we'll do select star from, where, order. So we can do sorting, grouping. All of that is possible. So you don't have to feel. So for example, if you go to our course management site, depending on the class, different lists come up. All we are doing is that means there's a table and it's being sorted in different ways. And even when you get to the participant list on the course page, you can sort and say, I want to sort by this, or get me all those whose last name starts with A, B, C. So what DBMS will do for you is allow you to have more queries to sort with. So we'll see those along as well. So as soon as I finish this talk part, we'll start some code implementation in the back so we can see all these things in action. She had a question. Okay, so consider that for information, for integrity, we should be able to talk about the same thing without any ambiguity or confusion. So for example, let's say you also wanted to have, whilst Batman was happening, whenever it was happening, you were also having your Batman movie in Ghana. About, I think there's a reggae star called Batman, or there's a singer called Batman, who's also doing a movie, right? So maybe there's the original Batman, not original, but at least DC Comics Batman going on, but you also want to have your Batman, right? Now, if all of these have almost the same details, maybe the same running time, all things are the same, it's still important, if we are talking about the same Batman, to properly identify whether or not we mean Batman the movie by our artist, or Batman the movie by DC Comics, right? It has to be consistent, and also if we are talking about that movie, so for example, if you do a query and you are getting the information, we want to make sure that what you get is accurate. So if, for example, the registrar pulls up your name along with your send ID, there shouldn't be duplicates in there, right? Or it shouldn't be that, oh, okay, she thinks she was editing your information, but she ends up editing someone else's information. At the very least, it's nice if the DBMS can offer some sort of integrity to say, this record you have pulled, this is the person. Right? And some of it, we human beings would say the rule. So we would say, oh, every student has an ID, right? Or every student should have a social security number. Some schools are like that. They don't take normal IDs. They'll ask that everybody should have a social before they start. Or everyone should have a national ID before they start. So there are different rules. But whatever rules people create, those will form the basis for the entity integrity. And that's what will go ahead and reflect in our designs. So the design I gave you was a very relaxed one. It didn't have any constraints. But we can start to add them in so that you can see that, oh, even though you've inserted the movies, you don't have 2-3 people inserting the same movie. You saw that yourselves. You inserted, and if you went to insert, you didn't complain. You just put it in there. Right? Even though you meant that it's the same movie, you were just trying to enter, it should have warned you, oh, this movie is already in the system. Right? So that's what we mean by entity integrity. Right? Everything has to be uniquely identified. Or at least uniquely identifiable. The second one is referential integrity, which we saw in the movie as well. For the design you did, if you had stars and movies, and you didn't even have the name of a star, you put it into the database, it still went in. Right? Meaning that it didn't have any referential integrity. So it didn't respect that, well, you didn't tell it to, nobody did. But it just said, well, as far as we know, there's a star called Van Damme doing maybe Bloodsport 5 in Ghana. So, is that Bloodsport? Okay, we'll have to do another one. I don't know how far they went with that movie. But, are you sure? Okay. Are you sure I didn't go to 2?
No.
Oh.
Is actually a biopic because martial artists
Okay. All right. So it's okay. So please calm down. So we just learned that Bloodsport was something that happened. So next time we watch it, we'll appreciate that it could have happened. It happened in real life. Yeah, because when we were watching, we were thinking it was all fake. You were thinking that could never happen. But now when I watch it, I appreciate that someone went through all of that. Right. Okay, so for referential integrity, that means that when we create our database systems, we want to make sure that if something is referring to something else, so for example, you sign up for a class, the list of students that I have must be actual students. They mustn't be fake students. Or if you are running a company and you are doing payroll, you don't want to have a list, the ghost name incident. So the people are saying, oh, ghost name. So the question is, how are they putting together the information? Right? Or even voters register, that's another one that's come up. People asking. Yeah, so those are the questions. People will say voters register. So someone will say, oh, but someone has a national ID card. So if so, shouldn't he have? So all of the things, anything at all, whatever the rules are, we have to look at it and consider, is this reflecting referential integrity? If I go to a hospital and I don't have a national health insurance card, but then somehow I am listed as I was treated under a national health insurance card, there is probably an issue. Right? So it means there's something wrong. That, okay, at the end of the day, they are listing all these patients whom they will claim have national ID or national health insurance cards, and they don't exist. Those are all referential integrity problems. Because if it did exist, it would be good to say, oh, this, when we go and check in the list of patients, we should make sure, if you say you are national health insurance, we should find your name also in the national health insurance list. Or social security. You go and take a loan as a student, so you claim from SNIT, but somehow they don't have your information, but you took the money. There's something about integrity going on there. So not just human integrity, but system-wide integrity. That if something should refer to something else, that thing must exist. Right? So that is really referential integrity. Hello, man.
If there is a record in table B, that you can't delete it.
It won't let you delete it. And that's fair. Because let's say students, right? You shouldn't just be able to go and delete a student. Before you delete a student, maybe you should unregister the person, remove all the details, remove all the things that are dangling in the system before you finally delete the student. And we do have this as well. So we don't actually delete students. We just change their status. Either they are currently enrolled, they graduated. We don't really do deletion. But often you can't. It's a good idea for the database management system to say, well, I've put in a movie. The movie says Van Damme. Nobody should be able to delete Van Damme if I'm referring to him. Right? If there's nobody referring to something, that is fine. You can remove it. That won't violate any rule. But the moment it allows you to remove something that someone is referring to, that will create a conflict. That means that, wow, that thing that person put there now is violating the rule of what? Referential integrity. Right? So that's why the DBMS will sometimes refuse to delete, refuse to update as well. So let's say in HSC, we know we should be either freshman, sophomore, junior, all the way to senior, then graduated. Or there's also transfer and then exchange students. And then somehow, someone wants to be having a new label that doesn't exist. Super senior, perhaps, right? Maybe that was super junior. We don't have that label. So to allow that to be selected and input, that means that there's an issue. Referential integrity is being violated. Right? I hope people are understanding this point. Right? So we see this also with electricity tariffs. People should be put onto plans. And recently, if you went to pay, especially with the mobile telecoms, if you go there, sometimes they'll tell you, you have to go to a new plan. The plans are coming. Pick one. You can't be there without a data plan, or you can't be there without any category. Some of us were without category. Because the first time the systems came, the earliest customers, we didn't have categories. I was just a customer. But now you go, they ask you, are you a business customer, or home customer, or a government customer? And I say, what does all that mean? So then they have to figure out what category to put me in, because without that, the service can't continue. They've made some rules, and I have to get a reference in their system that makes sense. So you need to have referential integrity for systems to work. All right, so we are going to start off by implementing some of these. Right, there are additional constraints that a database management system can have, such as checking to see if a value falls in a certain range. For example, you could say if it's an age, it shouldn't be below 0. Some DBMSs have the capability to enforce that. Or if it says a gender, you can only put M or F. That is also there. Or any other additionals that people want to call themselves.
So you can check, so like for a year, you can check the first number and the second number. So if it isn't from the 90s, that means the person doesn't fall in this category today.
Yeah, so there are some database management systems can have you, I think, not advertising, but Oracle has had that for a long time, where you can have a check. You can say check and specify the condition. And that means when the data is being inserted, the programmer doesn't have to do any extra work. It will just check and say, oh, no, this thing doesn't meet the values. I think MySQL does have, I think, like sets where you can check to see the value inserted, like gender, male, female. You can't just go and enter gender, Q. You have to say gender has to be M or F. The resolution usually is done by applications. And that was the example I gave with date. That if, let's say, I have an application where people are entering data from different locations, China, Ghana, so on. Even, let's say, 2 different locations, China and Ghana. If someone is entering from China and they say 9 a.m., my application, if it's smart enough, has to know this person says they are in China. So when they say 9 a.m., it should be what? Maybe 9 a.m. China time. Or if it's in Ghana, it should be 9 a.m. Ghana time. So some applications now, you see this with the likes of Gmail, asking you about what's your locale, what's your language, and what they'll do is when they see dates and times, they'll resolve it before they put it in. So you could put in your calendar in Ghana, travel to maybe New York or something, and then when you get there, pull your calendar, it would still be correct based on, because it knows that when the data was being entered, it was from this context. And when you get there, your entering data will be in that context, so you come back to Ghana. Yes, so you're right. So that is done in the background. You can either do it directly, telling the person, please pick your time zone. But a lot of applications these days, such as with your mail, you realize they don't seem to ask you. They just, from the first use, assume and keep. So it'll make it a little bit easy to use. and keep using the time that you were using, the time zone you were in. Okay, so we are going to move from, if people are okay with the theoretical aspects, what is entity integrity, referential integrity, we are going to move to the SQL part using Workbench, and then add on constraints, right? Create database tables with constraints. So are people cool? Everyone is cool. We are moving from here to Workbench. So I've explained two things: entity integrity, referential integrity. Now we are going to what? See these in action with SQL.